Okay, so I'm going to go over the DNA mutation simulation because I feel like that's going to be really helpful to some of you guys. I was grading them and I noticed that there were some people who were kind of confused. So hopefully this will help you and you can go back and redo or resubmit what you've already turned in, or and also if I've already graded it to you, you can still correct your answers and resubmit. So let me go ahead and put my screen into split screen for you guys. Okay, so on this assignment, you're supposed to click on the simulation. So I have that open here and it just starts like this. It says transcribe and translate your original DNA, review those terms, and write a short definition. So all we're going to do is click transcribe. And we're just going to watch what happens. Okay, so for our actual description of it or definition, we can say that DNA splits and mRNA is made from one side of the DNA. Okay, so now let's click on translate. Okay, so for translation, we can say the mRNA is read by the ribosome and tRNA molecules bring the amino acids to the ribosome to make a protein. Okay, so I think we're okay. Let me zoom out a little bit so you guys can kind of see everything at once. Okay, so now we're going to identify the major players shown in the simulation. These are the ones that we're going to label on this picture. Okay, so let's start with mRNA, and we can say this here, this strand here is mRNA, and then a codon would be just 3 bases, so I'm just going to put it under these 3. Maybe I'll just kind of center it. So one codon is 3 mRNA nucleotides. And then the next one is an amino acid. So like this one, leucine, that's 1 amino acid. And then your tRNA molecule here. And then an anticodon would be one of the triplets on the tRNA molecule. And again, all of these are in your notes too. So if you were stuck and you wanted to go to your notes for this, you can definitely do that. And then this larger molecule here in the background is your ribosome. And then these are all amino acids here. And so when you have a whole bunch of amino acids in a chain, that is how you get a protein. Okay, so now we're on number 3. When the protein is completed, write the sequence of amino acids shown. There are 11. And it says you can click the stop button to make it stop moving because I don't want to try and read that while it's moving around. So I'm going to click stop. And I'm going to start at methionine because we know that all of the amino acid chains start with methionine. So we're going to say met dash, and then the next one pro, and we're just going to keep going. And we're going to read that amino acid chain. Okay, so here is our protein, which is a sequence of amino acids. Okay, so now we're going to click on Edit DNA. So Edit DNA. And here is our original sequence. And we're going to edit DNA by changing all of the first triplet to AAA. So we're going to go here, and instead of ATG, it's going to say AAA. So there's the original, and here's how we're changing it. Now we're going to check the new protein created by your new DNA and describe how this changed the protein. So let's apply. And then now we're going to go back to translate. So we can tell so far all that's happened is that the first amino acid there, instead of having met, it's going to be LYS, lysine. So I'm going to go ahead and stop this. And it says, check the new protein created by your DNA. Describe how it changed. So we don't even actually have to write it all out again. We can just say the first amino acid changed from met to lys. So methionine to lysine. Okay, now it says return the triplet to its original state. So let's go back to edit DNA, and we're going to go back to having ATG right there. And then now place an additional A after the G. Your strand will read ATGA. So I'm going to add an A, and then I'm going to apply, and then I'm going to translate again. So this time, compared to our original, this one does start with methionine, but then it looks like everything after that, or everything after where the new inserted nucleotide is going to change. So kind of while that's finishing up, we can probably go ahead and start writing that. So I'm going to say the new protein starts with met like the original, but all of the amino acids after the additional A was inserted have changed. Okay, so now we're going to go back to edit DNA, and it says change it back to its original state, so we'll do that. Now change the second triplet from CCA to CCC. Okay, apply, and then translate. So it looks like so far we have same thing happening as what we had in the original, the same order. So I can kind of scroll back up too so you guys can see that. So met, pro, gly, glue, serlulu, isoleucine. Okay, so exactly the same. So what we can do, sorry, that was my alarm. Okay, so what we can do is just say that this did not change the protein. The amino acid sequence is still the same as the original. Okay, so then on the analysis questions, you created a point mutation in your DNA. Describe what a point mutation is and how this can affect the protein created by the gene. Number 8, the second mutation you explored is what's called a frame shift. Explain what this means and how it affects the protein. And the third mutation you explored is a special kind of point mutation called a silent mutation. Explain what this means. And I do think that most of you guys who already submitted this did okay on this part, but I'm sure you probably just looked it up, which is fine. But I think now that you kind of have, the correct answers up here, hopefully these 3 questions will make more sense to you, where in the point mutation, it can affect one amino acid. In a frame shift mutation, it's going to basically shift those codons from their triplet reading. And so you are going to have more amino acids affected. And then the third one, a silent one, is where just one mRNA base is changed. But if you think about the codon chart or the wheel, you can have the same triplet, or you can have, different triplets, I guess I should say, coding for the same amino acid. So that's why you could actually have a base be mutated, but it doesn't actually affect the protein. And that would be a silent mutation. So I would just go back over your answers, even if you've already submitted it, or even if it's already been graded, and just double check, see if you can fix anything, and then click resubmit, and then I can grade it from there again. And just always let me know if you have any questions.